So we got B and we got D. Okay, so let's actually work it out real quick. So what you're going to do is this is an example of limiting reactants. And if we take a look, let's say we start off with A. So then we have 2 moles of A that we're starting off with. And let's see. We look at our mole to mole ratio. So for every A, 1A, we have 1 AB. So it's a 1-to-1 ratio. So if we start off with A, we're only going to end up with 2 moles of A, B2. Now, if we start off with B, we're going to be starting off with 5 moles. We're going to look at that mole to mole ratio. For every 2 moles of B, we have 1 mole of AB. Okay. So we know that 5/2 is basically 2.5. Now, you're going to run out of one before you get to the other, right? So you always want to go with the one that has the smallest amount of moles that are being generated. So in this case, the correct answer would be the top one. So A is going to be limiting. Okay. So then if A is limiting, then we know that the mole to mole ratio that you need for B is a 1 to 2. So then it would be 2B up top. So we'd end up we'll need 4 moles of B at the end. So then that means that there would only be 1 left over. So Sol is correct on that one. So it's this one. Does that make sense? So like you got to think of it, the one that you run out of first,
Yeah.
that's going to cause how much we're going to be able to generate. So you guys are both quick. So I have to be on my A game here. Okay. So propane C3H8 is burned as a fuel in heating homes. Write a balanced chemical equation for this reaction. What is the coefficient for carbon dioxide? Okay. Saul believes it's going to be C. Okay. So I'm not so sharp. I have to actually write down the equation. So we know that there's C3H8, and we know that we're going to be needing oxygen since it's a combustion reaction, since burning's happening. We're going to end up with carbon dioxide plus water. So we know that we have 8 hydrogens on our reactant side. We have 3 carbons and we have 2 oxygens. On the other side, we have 2 hydrogens, 1 carbon, and 3 oxygens. So to balance this out, we're going to need a 3 here for our carbons. And so then that gives me now 7 oxygens. We're also going to need 4 in front of our water. So that ends up giving us 8 hydrogens. And then that'll be a total of 10 oxygens. So then we'll need a 5 in front of the O2. So coefficient is going to be 3. That is correct. Questions? Okay. Next question. In the net ionic equation for the following, what are the spectator ions? Okay, so Saul believes we have A. What do you think, Butch?
It looks like they all get used.
They all get used? Hmm.
Mhm.
Okay, so let me help you guys understand this. So in this case, what happens is that since this is an aqueous solution and these are ionic compounds, since they're ionic compounds, they're actually going to be broken up into their ionic species. So in this case, we're going to end up with NH4 plus AQ plus NO3 minus AQ plus, again, aqueous. So that means we're going to get the potassium ion, AQ, plus the chloride ion,
Mhm.
Cl minus AQ. Now, if we look on the other side, and I'll show you a little quick hint. On the other side, these are both aqueous again. Not one of them is a solid, not one of them is a gas, not one of them is a liquid. So they're not coming together. They're remaining as ions in solution. So in this case, all of them are spectator ions. So the correct answer would be all ions are spectator ions. And so as a result of that, that's not going to be a reaction because you're not going to have anything formed. Okay. So anytime that you see that both sides have aqueous aqueous and the other side has aqueous aqueous, then they're all spectators. Now, if you get the formation of water, water is a liquid. So then that's different, right? You're just adding liquid to your aqueous solution, but it's a liquid. You're getting the formation of water. So then that means that you're getting a product. Or if you get the formation of a gas, that means you're getting a product. Or if you're getting the formation of a solid, that means you're getting a product. So the other guys are just kind of there to help them get to where they want to be. Does that make
So,
sense?
so it requires a change of form.
That's right. Yeah. For it to be a real reaction. Yeah. Okay. This one is a hot mess. Let's see. Okay, so here we have this question. It says that we have 12.09 grams of A2 is going to react with 96.00 grams of B2, and that's going to form 108.09 grams of A2B. What is the ratio? What is the ratio of the molar mass of A to the molar mass of B? Okay. So the first thing that if we notice, we add these two together, right? The law of conservation says that what you put in, you should get out. Okay. So in other words, if we add both of these together, their masses together, it's going to have to equal the mass that we get out. So this should let us know that everything is going to be used in this case, right? Because we add this together, and that's going to end up being 108.9, right? Okay. So that keeps the law of conservation into check. The other thing that we want to keep in mind is that we have if we look at our ratio of how things are being done, right? So we also have for every two uh, A's we have, we're going to need one B. Okay. And so that's also going to be another factor that we need to take in consideration. So what we can do is the first thing is that we're probably going to do is look at the ratio that of what we're having for um, A to B ratio, right? So we have 12.09 over 96. Okay, so then that's going to be a 1 to 8 ratio, right? For our A to our B, our A2 to B2. Now, the other thing is that we know that we have a 2 to 1 ratio. So for every one of these that we're going to need, for every one of the A2 that we have, we're going to need just one. So then we're also going to have to double that amount. So in other words, for every one of A, we're going to need 16 of B. So the answer is the last one. Let me say for every one A2, we're going to need okay. Questions? Okay, number 5. List the number of atoms of each element in the formula unit ammonium sulfate. So we know ammonium. What is the chemical formula for ammonium?
NH4.
NH4. And we know that it's a +1 normally. We know sulfate, the formula for sulfate is
SO4.
SO4, and it has a
-2.
-2 charge. So for this to balance out, we need 2 ammoniums. And then 1 sulfate. So anytime that we have polyatomic ions, when they're in parentheses, that means that we have multiples. If they're not in parentheses, that means that we have 1 existing. Okay. So how many nitrogens are we going to have?
2.
2. So that means that we can get rid of these first 2. We know that those are wrong. And this last one, because we know that we have 2 nitrogens. How many hydrogens do we have?
8.
8. Okay, so that means it's this guy. And so we have 1 sulfur and 4 oxygens. Okay. Okay, how many atoms are in 0.188 moles of sodium? So we know that we have 0.188 given. Okay. And as Butch told me, it's going to be C. So we know that, let me do this, I get ahead of myself, moles of sodium. So for every 1 mole of sodium, we're going to multiply it by Avogadro's number, which is 6.022 times 10 to the 23rd. And that would be atoms. So we're going to end up with 1.13 times 10 to the 23rd. So that is correct. Okay. C, I mean, number 7. Okay. A coolant widely used in automobile engines is 38.7% carbon, 9.7% hydrogen, and 51.6% oxygen. Calculate the empirical formula of the compound. So the first thing that we're going to do is to do what? Okay, so we're going to make an assumption since we know that this here is going to represent percent mass. And so we're going to make the assumption that we have 100 grams of whatever we're working with. Yes, it is going to involve the weight of the elements. That is correct. So we're going to make the assumption that we have 38.7 grams. Because if our compound, we assume that we have 100 grams of our compound, that means 38.7 grams of it will be carbon. And then we're going to use the mass of our carbon. So carbon weighs approximately 12 grams per 1 mole. Okay. So that's going to give me 3.225 moles of carbon. Now, the reason that we're changing to moles is because moles is quantity. It's a form of quantity. And when we look at a chemical formula, we're comparing quantity to each other, right? So if we talk about oxygen to hydrogen in water, for every 1 oxygen, we have 2 hydrogens, right? And so the relationship between that oxygen and hydrogen is always going to be a 1 to 2. 1 oxygen to 2 hydrogens. And so in a compound, that's always going to be the case. And we're going to be looking at the empirical formula. We're going to be comparing them to each other. So then the other one is hydrogen. We have 9.7 grams of hydrogen. So I realized that I need to show my camera because I use my hands a lot. And it kind of helped me explain stuff. So can you guys see me? Good. Okay, so that's 1 gram of hydrogen, 1 mole. Then that one's going to be 9.7 moles. Oops. Of hydrogen. And then we have for oxygen, we have 51.6 grams of oxygen. So for every 1 mole of oxygen, it's going to weigh 16 grams approximately. So we're just going to divide by 16. Okay, so then what we're going to do is we're going to take the one that has the lowest number, and then we're going to divide it by itself and divide all of the other elements by it. So then we're getting the relationship of that one that's the lowest to all of the others. So in this case, carbon and oxygen are both 3.225, 3.225, and 3.225. Okay, so that means that we're going to have for one oxygen, we're going to have 3 hydrogens, and we're going to have 1 carbon. So our empirical formula is going to be CH3O. Okay, are you guys good? Now, if our numbers aren't whole numbers, right? These numbers here are not whole numbers when we do that division, then we may have to multiply them by something. So for instance, let's say that this guy was 1.25, right? And so in this case, if this was 1.25, we would try to multiply it by something that's going to make it a whole number. But we're going to multiply this one by it and all of the others as well too. So in that case, if this was 1.25, we'd multiply this guy by 4. We'd multiply this guy also by 4. So it'll be 3 times 4. And then we'd multiply our oxygen also by 4. So, okay. So if the number is, and I'll show you, if it ends with 0.25, you're going to multiply it by 4. If it ends with 0.2, you're going to multiply it by 5. If it ends with 0.1, it's close enough that you can round. You can get away with rounding. If it's 0.33, you're going to multiply it by 3. If it's 0.5, you're going to multiply it by 2. And then if it's 0.66, we're going to multiply it by 3. 0.75, we're going to multiply it by 4. And if it's 0.8, we're going to multiply it by 5. Okay. Any questions? Okay. We can move forward. Okay. Hard question here. It says, which of the following compounds is the best example of a hydrocarbon? So what is the definition of a hydrocarbon? Yes, something that has only hydrogen and carbon. So that means,
A hydrocarbon's a ratio of it works out to be a chemical ratio, right?
yeah, so it typically does work out to be a chemical ratio between your hydrogen and your carbon. And it just kind of depends on whether you have single bonds or double bonds or triple bonds. So, okay. So in this case, the best example would be the C, the third one. Because all the other ones, although like this is organic because it has carbon in it, and this guy is also organic, and this guy is also organic, but we're only talking about a hydrocarbon, which is hydrogen and carbon. So what is the formulas of the ammonium ion and the hydroxide ion in that order? Okay, we have A. Yes, that's right, Saul. It is the best example because it is the only example of a hydrocarbon there. Yeah. About the earlier question. So, but yes, the answer here is A. That is correct. Okay, next question. The complete combustion of C3H8O3 in the complete combustion of C3H8O3, how many moles of carbon dioxide are produced when 23.0 grams of C3H8O3 burns? So we're going to start off with our grams.
Sorry
H.
about the peacocks.
I didn't hear the peacocks at all. All I hear is my trains outside. Uh, I don't know what's going on. All of a sudden, we have all these trains coming through. Okay, so we're going to have to do what first before we can finish? So we're going to have to determine the molar mass of our compound. So we know that we have 3 carbons, we have 8 hydrogens, and we have 3 oxygens. So carbon weighs 12 grams per mole, and we're going to be multiplying that by 3 since we have 3 of them. Hydrogen weighs 1, approximately 1 gram per mole, and we're going to be multiplying that by 8. And oxygen weighs approximately 6 grams per mole, and we're going to multiply that by 3. So that's what, 48. That's 8. And that's 36. Okay, so then we're going to add those all together. So 92. So that's going to be 92 grams per mole. So we have grams here, so we want to put the grams on the bottom. So we're going to put the 92 on the bottom to get rid of our grams. And then we have 1 mole on top. So I'm gonna say it's so it's approximately a quarter, or it is a quarter. So 0.25. Okay, questions? Okay. Number 11. Which of the following defines percent yield for a reaction? That is correct. A. It's the actual over theoretical times 100. Okay, number 12. In a general chemistry laboratory experiment, a student produces 2.73 grams of a compound. She calculates the theoretical yield as 3.40 grams. What is the percent yield? Okay, that's right. It's going to be B. That is correct. So we know that it's going to be 2.73 is what she actually produced, grams. And we're going to be dividing it by the theoretical or the ideal. And so that's going to be 3.40 grams. And we multiply it by 100. So that should give us 80.3%. Okay. Calculate the mass of sodium oxide that can be produced by the reaction of 4.00 grams of sodium and 2.00 grams of oxygen. In a reaction, 4 sodium plus oxygen gas yields 2 sodium oxide. Okay. So you say E. Okay. So we can't make that assumption, right? Uh, so you're making the assumption that you're having a complete reaction with everything. So we actually are going to have to figure out which one is limiting, which one's going to run out first. It could be that neither of them are limiting, but more than likely, since you have two reactants, you have two values that you're given. So that probably means that one of them is going to be limiting. Okay, so then we're going to start off with the sodium. 4.00 grams. And if I remember correctly, sodium is about 23 grams per mole. Then feel free to correct me if I'm wrong. Oops. So let's do this. Since we want the mass, we're going to go all out. So we're going to do the multimole ratio of sodium to sodium oxide. So then for every 4 moles of sodium, we're going to get 2 moles of our sodium oxide. And then sodium oxide, so it's 2 sodiums. So that's 23 times 2, just 26. And 1 oxygen, so 16. So I'm going to add those two together. So that's 42 grams per mole. Okay, so for every 1 mole of sodium oxide, we have 42 grams. Okay, so this guy is going to be 3.65 grams. And then, that's right. And then we have the other one where we start off with oxygen, 2.00 grams of O2. So since we're talking about O2, so that means it's going to be 32 grams per mole. So now we're going to be looking at the ratio of oxygen to sodium. Oops. Okay, so that will be for 1 mole of oxygen, we have 2 moles of sodium oxide. Same molar mass as before for the sodium oxide. Did I screw up somewhere? So that's 5.25. Let me check something.
Get your massy or
Oh,
sodium oxide off.
up top. So it's
Yeah,
23 times 2. So that should be 46.
that's the sodium plus the oxygen would be another 16, right?
Yeah. So 46 plus, so that's 62. So this should be 62, not 42. If I could do math. Okay, so let's do that math again. 4 times 0.5 times 62 divided by 23 divided by 4. Okay, so this should be still wrong. Hold on. So 23 times 2, 46 plus 16, 62. Okay. So divided by 23. Okay. So this one is 5.39. And then this one is 7.75. Okay, so the correct answer is D, as in donkey. Okay. Okay. So let's go to the next one. Okay, so when C2H5Cl is burned in oxygen, chlorine gas is produced in addition to carbon dioxide and water vapor. 5,145 kilojoules of heat are released from every 4 moles of C2H5Cl burn. Which of the following correctly represents the thermochemical equation? Okay, so is the heat going to be on the reactant side of the equation or on the product side of the equation?
Product.
Okay, it's going to be on the product side because it's being released. That's right. Okay, so that means that we can get rid of this one. We can get rid of this one. Okay, so and we can get rid of this one because that one is like as if it's an intermediate. Okay. So in this case, which one is going to represent this here should be the delta H. Got to fix that symbol. So that should be delta H. So which one should represent exothermic or energy being released? The positive or the negative sign?
The positive would be the release.
Are you sure?
Apparently not.
Okay. So apparently not. That is correct. So it's the negative sign represent that energy is being released. So in this case, we're going to have it minus. When we say plus, that means that we're adding energy to the system. So it's plus
Okay.
that. Yeah. So the correct answer is the last one. Okay. Question 15. Which of the following correctly applies to the term solution? A, heterogeneous mixture. B, variable composition. C, consistent properties. D, dissolved particles can usually can let's see dissolved particles can are usually larger than about 10 minus 7 centimeters. E, exist only in the liquid and the gas state. So we know it's not going to be consistent properties. Heterogeneous mixture. So heterogeneous, when we make reference to heterogeneous, what does that typically mean?
You mean two different things.
Different, yeah. Okay. But in this context, when we're making reference to it, we're talking about the visual aspects of it. So if I have uh whiskey and water, I mean not whiskey and water, water and vodka. So can you see the difference between those?
To a degree, but not eventually over time.
Yeah.
When you first mix them, you can see the difference.
Yeah. Okay. So when we make reference to heterogeneous, typically we're making reference to, although it can be a solution, a heterogeneous solution, but it makes reference to what we see visually, right? But what you're trying to say most likely is variable uh, composition. So when we're talking about that, we have two different things that we're looking at, right? So more than one item that's in there. Does that make sense?
Not exactly.
Mm. Okay.
So
So
variable composition would be that there are different elements in that solution, yet they're indistinguishable.
yeah, so you could have two different elements or you could have two different compounds.
Yeah.
Does that make sense?
Yeah. There's
Yeah.
two different substances, but
They look the
they're
same. Yeah.
indistinguishable.
Yeah. So, and
Okay.
that's typically what we call homogeneous, right? So this is a more general definition, general term. This one is a very specific. Does that make sense? So like if I'll give you an example. If I put um salt and pepper together, right? So we can distinguish between salt and pepper visually, right?
Correct.
But it's being mixed together. It's a mixture, it's a solution. If I put milk or oil and water, right? We can
Mm-hmm.
distinguish between those. It's going to be a solution, but they're going to be separated from each other almost automatically, unless I shake them up and they form the little pockets of oil bubbles, right?
Mm-hmm.
Okay. So, but if I put, like you said, I put vodka and water together, if I mix it together, you can't see the difference between them, right? So, but they both vary in their composition, right? They're all vary in their composition of what's there. So
Okay.
that would be the best. This is a kind of crappy question.
Yeah.
Yeah. Okay, so convert 17.4 nanometers to millimeters, gigameters, and I'm going to assume uh, tera, terameters. Okay, so we have 17.4. And if we do the very first one, it'll help everything. So let's start off with the very first one. So we know that it's nanometers, right? That's what we're starting off with. Nana, Nana starts with N, 9 starts with the N. So I always remember that 10 to the ninth nanometers will equal 1 meter. Or we could do it here where they said 1 nanometer is 10 to the minus ninth meters. And then I know that 10 to the 6 meters will equal 1 megameter. So that would be 1.74 times 10 to the negative 15, negative 14 megameters. So all of those are going to be incorrect. And this is going to be my correct answer. Okay. Okay. See, for the relationship shown, see, consider the following graph. For the relationship shown on the graph, what are the values of M and B relative to the equation y equals mx plus b? Okay, so B represents, okay, so we said E. B is going to represent the y-intercept. So we know that the y-intercept is going to be at 8. So we can get rid of all of these because it should be M and this should be B. So it's going to be one or the other of these two. Now, the fact that as we move in this direction, the graph is going down, so that means that it's going to be rise over run, right? So in other words, or decline over run. So in other words, we're going to go down and over represent. So it's going to be a negative value since it's going in a downward slope. So the correct answer would be the last one. Okay. Very funny. Okay, Faraday's law of electrolysis states that the mass of a substance produced at an electrode during electrolysis, M, is directly proportional to the number of moles transferred at that electrode, N. Which of the following equations correctly characterizes the relationship? Okay, so there's a couple of words that we want to pay attention to. One is equations. So we know that M is proportional to N. To make it so that it's equal, we need to have a constant. Okay, so M is going to be equal to a constant times N. So we know that it's not going to be this one because it's directly proportional. Directly proportional basically means this one goes up, the other one is going to go up. Okay. Now, by us making it equal to each other, we have a constant that allows that to be maintained. And so the correct answer is A. Does that make sense?
Mhm.
Okay. So for a fixed amount of a gas at constant volume, the pressure P of that gas is directly proportional to its absolute temperature. So we're saying P is directly proportional to temperature. Okay. Which of the following is the best choice of units of the proportionality constant that relates P and T in an equation? So we're saying if we say that P is going to be equal to KT, what is going to be the units of T? So we know that units for temperature, and they tell us absolute temperature. So what does that mean? Kelvin, that's right. So we're going to be using Kelvin. So we can get rid of this guy, we can get rid of this guy, we can get rid of that guy. So we're going to be using these two these two options, right? So the units for this to be true, atmosphere is the units that we use for pressure. So do we want atmosphere on top and Kelvin on the bottom, or do we want Kelvin on top and atmosphere on the bottom? Now, we're going to be multiplying K by T, and it has to equal atmospheres on the other side. So for the units to cancel out, do I want K on the bottom and atmosphere on top? Or do I want K on top and atmosphere on the bottom? That's right. So the answer should be A. So I want atmospheres on top because I want the units to cancel. If they're right next to each other, this would be K squared or Kelvin squared over atmosphere. Okay, which we don't want. Okay, the next one. Which of the following is the correct classification of both calcium and iron? A, calcium is a transition metal and calcium is a transition element and a metal, and iron is a transition element and a metal. B, calcium is a transition element and a metal. Iron is a transition element and a nonmetal. C, calcium is a main group element and a metal. Iron is a transition element and a nonmetal. D, calcium is a main group element and a metal. Iron is a transition element and a metal. E, calcium is a main group element and a nonmetal. Iron is a main group element and a metal. So that's right. It is D as in donkey. So we know that calcium is a main group because it's in group 2. And then it's also a metal. And then we know that iron is a transition element and a metal. Ugh. Sorry. Okay, so how are we doing on time? Too bad. So which of the following statements is true? Given the atomic number of an element and the atomic mass of the element can be calculated. B, an isotope is identified by its mass number. C, the number of neutrons in an atom determines the chemical reactivity of the isotope. D, the total contribution of mass of an atom from protons and electrons varies among the atoms, the atoms of the so the varies among the atoms of an element. Mass difference among atoms of an element cannot be accounted for with our current understanding of the atom. So you said B. Everybody says B. B is correct. Okay. Number 22. Considering the following figure, which represents an element block on the periodic table. If this is a block for the nonmetal found in period 3, group 5, the question marks 1, 2, and 3 should be filled in and respectively, which of the following? A, 33 AS 74.1, 0.92. B, 23 B 50.94. C, 15.15 P 30.97. E, 39 Y 88.91. So C is correct. One of the main features of Dalton's atomic theory, no longer considered valid, is atoms cannot be created or destroyed. Which of the following is the best explanation of why this feature is no longer considered valid. A, the percentage of a mass of an element in a compound is always the same. B, in a chemical change, mass is neither created or destroyed. C, every atom contains an extremely small and an extremely dense nucleus. D, when two elements combine to form more than one compound, the different weights of the element that combined with the same weight of another element of the other element is in a simple ratio of whole numbers. And E, the discovery of subatomic particles. That is correct. It's E. 24. The natural distribution of the isotope of a hypothetical element is 60.795% at a mass of 281.99481 units. 22.122% at a mass of 283.99570 units. The remaining mass of so the the remainder has a mass of 286.99423 units. Calculate the atomic mass of the element. Okay. So the way that we'd go about doing this is we're going to take the percentage. We could either make it a decimal or we can leave it as a percentage and then just divide by 100 afterwards. So we could take that 60.795% and multiply that times this value, 281.999481 units. And then we're also going to do the same thing here with the 22.122%. And we're going to multiply it. Looks like a plus. And the remainder is going to be 17.083% times 286.994 0.23 units. Okay, so that's going to be 5 sig figs that we're going to be working with here. And then 60.795 times 281.99481. Okay. So then we're going to add them together. Okay, so we ended up with 28,328.3, and we need to divide it by 100. So since this is percentage, so 283.28 units. Okay. Questions? Okay, next one. So which of the following name formula pair is/are correct? Sodium ion. Is that one correct? Yes. Okay. So I'm going to put a check by it. Okay. 10(2) ion. Is that correct? No, that's right. So it needs to be SN for 10. Silver ion. Is that correct? Yes. Fluoride ion. Is that correct? Are you sure? What is the symbol for fluoride or fluorine? F. That's right. It's just F. Okay. The manganese 3 ion. Is that correct? Yep. Okay, so our answer should be 1, 3, and 5. Okay. So for each of the following names, choose the correct formula. Oxide, silver, oxide ion, silver ion, manganese 2 ion. So is it O2 2 minus, Ag plus, Mn 2 plus? Is it B, uh, O2 minus, Ag plus, Mn 2 plus? Is it C, O O2 2 minus, Ag plus, Mn plus? Is it D, O2 minus, Ag plus, Mg plus? Is it O2 minus, Si plus, Mg plus? So, okay. So, since we're talking about the ion, the oxide ion, it's not it's not diatomic. It's monoatomic because we're talking about just the ion. So the correct answer would be B. And we know that these guys are not correct because this is magnesium and not manganese. And we know that the Roman numeral tells us the charge, so it needs to be a +2. So we know that these guys are not correct either. This one isn't correct. Okay. Number 27. What are the names of the compounds Hg2Cl2 and Zn3 parentheses PO4 close parentheses 2? I always have to catch myself on these type of questions because I want to say the name. So is it A, mercury 2 chloride, zinc phosphate, B, mercury 2 chloride, zinc 2 phosphate, 3, mercury 2 chloride, zinc 3 phosphate, uh, D, mercury 1 chloride, zinc phosphate, and E, mercury 1 chloride, zinc 2 phosphate. So this one is a little tricky. So it is mercury 1 chloride. However, zinc is always going to be a +2 charge, so we don't have to put the Roman numeral there. So we always say just zinc instead of zinc 2, since it's always going to be that charge or that oxidation state. So the correct answer is actually D as in donkey. Okay. And let's talk about the exceptions, those exceptions like zinc. So the exceptions are going to be, so as I mentioned, we have zinc is always just going to be zinc. We have cadmium is always going to be a +1 charge, so it's going to be just cadmium. And then silver, there's one more, but I can't remember off the top of my head. So, but those are the three that I can remember. The other one that I can't remember, it'll come up here in a minute. It always does. So So, but those are the exceptions where you don't have to, you're not going to use Roman numerals with. Okay. Examine the name given on the following laboratory reagent container. The formula has been washed off the container. What formula should be placed on the container? Question mark. And what is the formula of the anion formed by this acid? Acid's total ionization in water, respectively. Okay. So we have C. That is correct. So sulfuric acid is H2SO4, and the anion is going to be SO4 2 minus. Ugh, sorry. Okay. What is the name of CuNO3 close parentheses 2 dot 3 H2O? That's right. That's right. So we know it's going to be copper 2 because nitrate has a -1 charge, and we have two of them here. So we have to use copper 2. And then we have 3 waters. So it's trihydrate. Which of the following is the correct formula for the hydroxide ion? You guys, we've already answered this one. Yep, that is right. C. Okay. A compound is analyzed and found to contain 0.279 grams of carbon, 0.0469 grams of hydrogen, and 0.124 grams of oxygen. Its molecular mass is 116 grams per mole. What is its molecular formula? So the first thing that we want to do is find its empirical formula. Okay. So we're going to do the same thing that we did earlier. We're going to find the number of moles for each of the different elements. So it's 12 grams, 1 mole. Zero, 2, 3, 2, 5. Moles of C. Then we have hydrogen, which is 0.0469 grams of hydrogen. we know that hydrogen weighs 1 gram per 1 mole. And then oxygen, we have 0.124 grams of oxygen. We're going to divide that by 16 grams. That's for every 1 mole of oxygen. So we're going to divide by the smallest again. So divide them all by the same. Okay, so our empirical formula is going to be C3H6O. Okay, so then what we're going to do is we're going to take its molar mass. So we have 3 times C, which is 12 times 3. And that equals 36. And then 6 times 1, or 1 times 6, because hydrogen weighs 1, and we have 6 of them. And then we have 1 oxygen. So that's 16 times 1. Okay, we're going to add those together. So it's 58 grams per mole. So we have its molecular mass. So we're going to take that 116 grams per mole and divide it by our 58 grams per mole. And that should equal 2. So then if we multiply this equation by 2, C6H12 O2. So C would be our correct answer. Okay, questions? Concerns? Just long problem.
Yeah.
Yeah. Okay. So I'm going to try to get two more, maybe three more done. Okay. So how many grams of calcium are in 5.00 grams of calcium hydroxide? Well, one thing we know, we can get rid of the ones that are really dumb answers. So we know that this one is a dumb answer because you can't have more than what you actually have, since law of conservation. Okay. So what we're going to do is we could take the percent, get the percent mass of our calcium hydroxide. So we know that calcium is going to be calcium hydroxide is going to be Ca, parentheses, OH, close parentheses, 2. So that means that we're going to have one calcium, two oxygens, and two hydrogens. Okay, calcium is what, 40? It's approximately 40. Oxygen is 16 times 2, which is 32. And then hydrogen is 1 times 2. So add that all together, we get 74 grams per mole. And so if we take our 40, since we have one calcium, divide it by 74 times 100, and that's going to give me my percent mass of calcium in calcium hydroxide. Okay, so if we want to figure out how much uh, calcium is in our calcium hydroxide, so we could just multiply it by a percentage here. So 5.00 grams times, or our fraction of that, so 0.54. So we're going to end up with 2.70 grams of calcium. Okay, questions? Okay. Which of the following is the best definition of atomic mass? A, the average mass of an atom, average mass of atoms of a an element compared to the mass of the atom of carbon 12 at exactly 12 atomic mass units. B, a property reflecting the quantity of matter in a sample. C, the mass of an atom measured in SI units of mass, the kilogram. D, the number of grams in a mole of substance. E, the mass of the number of carbon atoms in exactly 12 grams of carbon. What do you guys think? Atomic mass. So you said B, the property reflecting the quantity of matter in a sample. Yeah, so the atomic mass would be, you're right, yeah, so that would be too vague for a definition. So it's not going to be B. So D wouldn't be correct because that would be the molar mass, right? Because that would be for a mole of what we're talking about. So we've gotten rid of one is way too vague. This one is way too vague. This one is for molar mass. We know that it's not measured in kilograms, so we've gotten rid of that. Okay, so we also know we're not talking about the grams, so we can get rid of that one. So what's left? So correct answer is A, which is so weirdly worded. Okay. Okay, so let's do number 34 and 35, and then we'll call it a night because my brain is about fried. Is that fair? Or is there one in particular you want to do? Okay, calculate the formula mass of aluminum carbonate. Okay, first thing we have to do is write the chemical formula for aluminum carbonate. Can you guys help me out with that? Again, brain fried. Okay, so it's AL, capital A, lowercase l, capital C, capital O, capital. Okay. Is there anything else that we need to add to that? What is the charge on aluminum when it forms an ion? That's right. It's Al3 plus, right? And what is the charge on carbonate? Mm, no, not -1. It's going to be 2 minus if you look on your polyatomic ion table. So In that case, we're going to need two aluminum and three carbonates. Okay, so we have aluminum. We have two of them. And aluminum, if I remember correctly, weighs about 27 something. Yep, about 27. Okay, and then carbon, we know weighs 12, and we have three of them. And oxygen, we're going to have a total of nine, and that's, oops, so 16 times 9. Four, 6, and 54. Okay, we add those all together. So that's going to give us 234 AMU or A or MU or just U. Okay, that's right. E. You guys are quick. Okay, last one, and then we'll call it a night. Okay, consider the hypothetical chemical reaction represented by the equation 3A plus 2B yields A3B2. Which of the following is the correct interpretation of this equation? 3 grams of A reacts with 2 grams of B to form 1 gram of A3B2. Or 3 atoms of A reacts with 2 atoms of B to form 1 molecule of AgB2. Or 3 moles of A reacts with 2 moles of B to form 1 mole of A3B2. Okay. So do you guys think it's one only? Yes, no.
Isn't it all three?
But no, it isn't all three. Nope. Because this is mass, right?
Okay.
So because it's mass, it's not going to be the same as quantity, right? So our mass
Yeah.
is not the same as our quantity. You're one person, you weigh how much you weigh, right? So I'm one person, I weigh 225. So,
Mhm.
and so my mass is not the same as my quantity, okay? So when we talk about this chemical equation, this is representing quantity. It's not representing mass. So we know that that one isn't right. So doesn't atoms, the number of atoms, isn't that quantity?
Yes.
Okay,
Should be two and three.
that's right. Okay, so it's D as in donkey. Okay, well, I'm beat. I still
Okay.
have tons and tons of grading to do. Good luck on the exam. Be careful. Like how you read these questions, particularly the ones with balancing. Make sure you're paying attention to whether you're getting a sum or you're getting whatever the coefficient is. And don't forget when you don't have a number in there that's understood to be one.
Okay. Thanks for
Okay.
your time tonight.
Yeah, you're welcome. You guys have a good night and good
Mhm.
luck on everything.
Thanks.